Hello friends, grab your coffee, grab your cookie, but today, keep both very far away from any polishing wheel or metal grinder because we are talking about 5 of the most dangerous metal dusts found in manufacturing. These include lead dust, magnesium dust, cobalt dust, titanium dust, and brass dust. Each one behaves differently, each one has unique hazards, and each one demands its own engineering approach. I am Michael Klepik, and for the past 15 years, I have designed dust collection and air purification systems for metalworking, aerospace, battery plants, machining shops, foundries, and explosive metal facilities. Today I want to walk you through these 5 dusts, quickly, clearly, and with enough engineering detail to make your coffee taste smarter. Technical description of 5 metal dusts. These 5 metal dusts differ drastically. First, lead dust has extremely fine particles ranging from 0.1 micron to 20 microns, with a bulk density reaching 9,000 kilograms per cubic meter. It consists of lead metal, lead oxide, and lead sulfate, and is biologically toxic. Second, magnesium dust ranges from 1 micron to 50 microns, has a bulk density of 1,000 to 1,700 kilograms per cubic meter, and is extremely reactive with oxygen and moisture. Third, cobalt dust ranges from 0.5 microns to 20 microns, with a density from 3,000 to 5,000 kilograms per cubic meter. It is toxic, allergenic, and carcinogenic. Fourth, titanium dust ranges from 1 micron to 40 microns, with a density near 1,000 to 1,700 kilograms per cubic meter, and is highly explosive as a combustible metal. Fifth, brass dust, which is a copper and zinc alloy, ranges from 1 micron to 30 microns, with a density from 4,000 to 7,000 kilograms per cubic meter. It is conductive, abrasive, and partially combustible. 5 metals. 5 completely different engineering challenges. Where these dusts are generated, these dusts appear in very different industries. Lead dust appears during battery recycling, ammunition manufacturing, smelting, soldering, and oxide mixing. Magnesium dust appears in aerospace machining, die casting, automotive lightweight alloy production, and pyrotechnics. Cobalt dust appears in superalloy grinding, battery cathode production, thermal spraying, and magnet manufacturing. Titanium dust appears in additive manufacturing, orthopedic implant machining, aerospace machining, and metal powder handling. Brass dust appears in polishing, machining brass fittings, valve manufacturing, instrument manufacturing, and casting cleanup. You can think of these 5 dusts as a tour through some of the most challenging sectors of modern manufacturing. Why these dusts are dangerous to human health. Each metal presents unique health risks. Lead dust is a neurotoxin that causes kidney damage, anemia, and neurological impairment. Magnesium dust forms magnesium oxide fumes that irritate the respiratory system. Cobalt dust is carcinogenic, causes asthma, and creates strong allergic reactions. Titanium dust, when burned or inhaled as oxide fumes, irritates lungs and causes inflammation. Brass dust, with copper and zinc oxides, can cause metal fume fever and respiratory irritation. 5 metals. 5 different OSHA health hazards. Combustibility and reactivity. Not all metal dusts burn, but the ones that do are extremely dangerous. Lead dust is non-combustible but spreads contamination during fires. Magnesium dust is violently combustible and reacts with water to generate hydrogen gas. Cobalt dust becomes combustible when finely divided and heated during grinding. Titanium dust is highly explosive and falls under the strict rules of NFPA 484. Brass dust is partially combustible due to zinc content and can ignite from sparks. Magnesium and titanium are the most reactive, while lead is the least, but every metal requires control. Behavior of each dust in airflow. From an engineering perspective, lead dust is heavy but stays airborne as extremely fine smoke-like particles and sticks to surfaces electrostatically. Magnesium dust is lightweight, accumulates static charge, and ignites easily from friction. Cobalt dust is extremely fine, deeply penetrates filter media, and embeds aggressively into surfaces. Titanium dust remains airborne easily and ignites from hot chips or static sparks. Brass dust is conductive, abrasive, and settles in duct elbows and fan housings. You cannot treat these dusts like ordinary nuisance dust. The airflow behavior is completely different. Best filtration equipment for each metal. Torch Air uses different technologies for each metal dust. Lead dust, I prefer the Foan HEPA Plus cartridge collector or the Blizzard Lead Safe Baghouse, both with fully sealed HEPA final filtration. Magnesium dust, I select the Tornado Dry Inertial Collector or the Cyclone Vulcan because they operate without fabric filters that could ignite. Cobalt dust. I use the Fusion Ultra Cartridge Collector or the Blizzard Cleanroom Edition for battery-grade powders. Titanium dust. I use the Cyclone Titan or the Tornado Inert Bed Scrubber, both designed for spark-free, inert operation. Brass dust. I select the FOEHN Conductive Cartridge Collector, the abrasion-resistant Blizzard AR Baghouse, or a compact Bora filter at polishing stations. 5 metals, 5 different filter strategies. OSHA and NFPA compliance requirements. These metals fall under multiple strict U.S. regulations. Lead dust, OSHA lead standard 29 CFR 1910.1025, magnesium and titanium, NFPA 484 for combustible metals, cobalt dust, OSHA carcinogen exposure guidelines and respiratory protection, brass dust, OSHA copper and zinc exposure limits. Additionally, first, housekeeping must prevent dust accumulation. Second, explosion isolation may be required for combustible metals. Third, fourth, proper respirators must be provided when engineering controls are not enough. Fifth, HEPA filtration is mandatory for lead and cobalt. Dust collector system designed for 5 metal dusts. Because these metals behave differently, a dust collector must be engineered for the specific hazard. I design, first, differential pressure sensors to monitor filter condition, especially for HEPA systems in lead and cobalt operations. Second, spark-free and non-fabric inertial collection for magnesium and titanium to prevent ignition. Third, fully sealed negative pressure systems for lead to prevent contamination leaks. Fourth, conductive ductwork and bonding for brass dust to prevent short circuits and static buildup. Fifth, automatic dust discharge systems appropriate to each metal, steel drums for heavy lead dust, inert media drums for magnesium, stainless sealed containers for cobalt, and reinforced bulk bags for brass. Sixth, abrasion-resistant inlets and ceramic-lined elbows for metals like brass and cobalt that erode steel. Seventh, multi-stage filtration, including HEPA polishing stages for toxic metals such as lead and cobalt. This is not one universal solution. It is 5 different engineering systems living inside one integrated design philosophy. Lead, magnesium, cobalt, titanium, and brass dust are 5 of the most challenging and hazardous metallic dusts in industry. They differ in toxicity, reactivity, airflow behavior, and regulatory requirements, and each demands its own filtration and safety strategy. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, metal belongs in your product, not floating in your breathing zone. See you in the next video.